Hello dear students, welcome to Pen and Paper Chemistry. Today's lesson we will be completing the properties of haloalkanes, hence this is part 3 of the video on properties of haloalkanes. What do you need in order to continue with watching the video? You need a pen, a paper, your old calendar on which you may have drawn the flowchart earlier, and of course some colored pencils or sketch pens to make your learning very easy and super smooth. This is what I've got for you. So this is a flow chart. For those who've been following the channel earlier, I have been giving flow charts to make your learning easy under organic chemistry. So continuing with the flow chart, we are talking about the properties of haloalkanes. And in this particular video, we are going to complete the discussion of reaction of haloalkanes with metals, their reduction, and some more properties. What you have to do is you have to add these reactions to your original set of the flow chart where we wrote reactions on nucleophilic substitution, because these are also properties of haloalkanes, right? So we go ahead. So the first property that we are talking about under haloalkanes today is the reaction with metals, and I have listed 3 metals over here, although there are reactions other than that as well. You can follow according to your curriculum. So the first one we've got is the reaction of haloalkanes with magnesium in dry ether, which acts as a solvent, because we know that haloalkanes are not soluble in water. This gives us Grignard's reagent. So let's get going and write the reaction. Alkyl halides react with magnesium in dry ether to give us a very important class of compounds which are generally categorized as organometallic compounds. So if you notice, the word is organo means organic, metal, compound. A compound of an organic substance with a metal is an organometallic compound. Specifically, the alkyl magnesium halides are categorized as Grignard's reagent. And Grignard's reagent are a very important class of compounds because they are the starting material for a number of organic compounds. So you can prepare carbonyl compounds using Grignard's reagent. You can prepare carboxylic acids, you can prepare, and you can also prepare a number of nitrogen derivatives. We shall talk about this topic separately using Grignard's reagent. So hence they are very, very important synthetically. That means we can prepare or synthesize a number of organic compounds. So would you like to try writing the reaction of C2H5Br with magnesium in dry ether? Go ahead. So this part C2H5 is your R according to the general equation. So go ahead, we will write C2H5 and then magnesium bromide, right? It is something like MgBr2 is your magnesium bromide. Here one of the halogen is replaced by the alkyl group. So you can understand it this way. So this gives us ethyl magnesium bromide as our product. Hence alkyl halides can be used to prepare organic metallic compounds, specifically Grignard's reagent. Similarly, we have already dealt with the reaction of alkyl halides with sodium in dry ether. Do you remember this reaction? We had drawn a box also. Can you recall where we did this reaction? So R dash X, and you had sodium and you had dry ether, and we drew a box over here. Yes, it is already there in one of the topics that we have already covered. Very good. So we get an alkane over here, R dash plus 2NaX, right? So R dash, this is an alkane. Now how is this an alkane? Now in case you have not revised alkanes for a long time, just to brush up what we have already covered. So C2H5Br, sodium metal. Now I am going to flip this. So BrC2H5. I am just flipping it around to make it easier for me to remember and write down my reaction. Okay, here we are not talking about the stereochemistry at all. Go ahead, make the box, and what do we get? C2H5 single bond C2H5, which gives me C4H10. And what is C4H10? Very good, it is known as butane. Can you recall what is the name of this reaction? If you are not able to, just close your eyes for a minute. Go back to the flow chart that we did for the preparation of alkanes, and it will slowly come back to you. If you have done that topic, definitely great. It is known as the Wirtz reaction, a very important reaction in organic chemistry. Why is it so important? So we started with an alkyl halide which had 2 carbon atoms. We ended up with an alkane which has double the number of carbon atoms. That means we end up with 4 carbon atoms. Hence, this particular reaction is used for ascending a series of conversions. Ascending a series means if I want to convert from a 2 carbon to a 4 carbon. So let's suppose I want to prepare C4H9Br from bromoethane, if I want to prepare from this. So what if you notice over here is 2 carbon is getting converted into a 4 carbon. So what we are going to do over here? Yes, so we are first going to convert the C2H5Br to C4H10, that is butane. And how are we going to do that? Very correct, we are going to do it by the Wirtz reaction. And then what do? We know that alkanes undergo halogenation, right? So we reacted with bromine, although you will get a mixture of products. So C4H9Br, the simplest that we can write at the present according to your present level of understanding. Okay, there are variations in the reactions which we will study through the course of your understanding of organic chemistry, right? So this is what we say ascending, going from a 2 carbon to a 4 carbon product. That could be the same functional group or that could be a different functional group. Similarly, alkyl halides react with lithium metal to give us another class of organometallic compounds, that is the alkyl lithium. So RLI. Can you fill in the blank for me here? Go ahead. And also a very important point over here, that we are carrying out this reaction in the presence of dry ether, right, as one of the solvents. So LiBr is our side product. Similarly, it can react with other metals like zinc, mercury and so on. Let's go on to the next set of reactions. Now this particular reaction again we have already discussed under the preparation of alkanes. Does it remind you of something? Correct. So by the reduction of an alkyl halide we get an alkane RH plus HX. Now if you notice in the reaction, the condition I have written is H2 or nascent hydrogen, or you will have lithium aluminium hydride or sodium borohydride. Anything can be used over here, various reducing agents. So what we've got, so for example C2H5Br, it can be reduced using any of the reducing agents. So like you can use platinum, palladium or nickel with hydrogen. Very good. And do you remember where heating is required and where room temperature will do? Go ahead, write the conditions of the reaction. Then we could use zinc, copper, couple and alcohol, which generates hydrogen in the reaction mixture itself in situ, and that is called the nascent hydrogen. Then we've also got a red phosphorus and HI. That's another of the reagents that we have written. We've already mentioned lithium aluminium hydride or sodium borohydride as the reducing agent. Then other reducing agents are like the chemical reducing agents, zinc plus an acid, tin an acid. So all these reducing agents, what are they going to do? Remove the halogen, replace it by a hydrogen. So we have C2H6 plus, go ahead, because I've got H over here, it will be HBr, correct? So again, this is a reaction where I can use it for converting, but the number of carbon atoms is remaining the same. Clear? So would you like to try one more reaction? CH3Br reduction. What will you get? Write each reaction 2 times at least for more confidence in the concept. Okay, now that we have covered 2 of these, let's go on to the next set of reactions. So we're going to talk about elimination, halogenation, Friedel-Crafts alkylation. Now if you notice over here, elimination is giving me an alkane. So where do you think we would have done this reaction? Absolutely, we have done it in the preparation of alkenes. So we have, for example, CH3CH2Br in the presence of alcoholic KOH or alcoholic NaOH. It is the elimination the reaction which takes place, CH2 double bond CH2 plus HBr. Now halogen goes from the first carbon and hydrogen from the next carbon. The carbon attached to the halogen is alpha hydrogen, the carbon next to it is the beta hydrogen. That is why this reaction is also known as beta elimination, and it is helping us to convert from a saturated to an unsaturated compound. Can you recall how do we convert an unsaturated to a saturated compound? How is this possible? No, this reaction is not reversible. Yes, we do it by addition reaction. So you can add hydrogen halide or hydrogen or a halogen molecule depending upon what we want to prepare in this particular reaction. So I've written the bond line notation. Now see over here, I am taking the same thing, CH3 CH2Br, right? It's nothing different. I've just written the expanded notation so as to make the concept clearer. So this is our alpha carbon, this is our beta carbon. Halogen leaves from here, the hydrogen leaves from the adjacent carbon, and we have the product CH2 double bond CH2, right? you can also write this product as CH2 double bond CH2. Becomes easier, right? Now, the next what I am giving you to try is, you've got 2-bromobutane, right? So let's number it 1, 2, 3, 4. So you've got 2-bromobutane over here. Now you carry out the dehydrohalogenation, removal of the hydrogen and removal of the halogen, or what we also call as beta elimination reaction, in which single bond is getting converted into a double bond. Now if you notice over here, now can you tell me the products which will be formed in this reaction? Okay, so what we've got over here, CH3CH, so bromine goes from here, hydrogen goes from this carbon atom, right? Because there are two adjacent carbon atoms, so you can have a 2,3 combination or a 2,1 combination. So CH3CH double bond CH, CH3. Can you name this compound? 1, 2, 3 and 4, prop 2 ene. Is it prop? No, it is bute, because there are 4 carbon atoms, right? So we have bute 2 ene as our product. Whereas if we take the halogen from one carbon atom and the hydrogen goes from this carbon atom, in that case we have the second product over here. Now which one would be formed, or is it that both will be formed? First of all, let's name this product 1, 2, 3 and 4. So you have either, we can call it just as butene or bute 1 ene, right? So which of these would be our major product? Again, please close your eyes, try recalling the Zaitsev rule, which is also written as the Zaitsev rule, which says that whenever you have a choice of the elimination products, it is always the more highly substituted one which will be formed in the major amount. Again, we have already discussed this in great detail under the heading alkenes, because this is a reaction which is used for the preparation of alkenes. So we've got bute 2 ene over here as our major product. What does the rule say? That when we have a choice of elimination products, it is the more substituted product which will be formed in greater amount. If you are unclear about this statement, I have made a separate video on the preparation and properties of alkenes. Sincere request, if you can visit this video and clear your concepts, it will make life much easier for you as well. The next reaction we are talking about is halogenation. Now halogenation, that was one of the first reactions we did, where we did the reaction of, do you recall, methane with chlorine or methane with bromine, and what did you get? Yes, you got a number of products. That is why in these products I have written here mixture of halogen derivatives of alkanes. So let's suppose we react methane with chlorine. I know I am doing methane with chlorine, and this is done in the presence of ultraviolet light or diffuse light. So we've got over here CH3Cl plus HCl. Now this can further undergo substitution, and what type of substitution reaction is this? It's a free radical substitution reaction. Again, mechanisms have been discussed separately under the headings principles or basic fundamentals of organic chemistry. and they will be very helpful for you in order to understand how organic compounds behave. So this reaction can go down up to CCl4, but since there are a large number of molecules in a very small sample also, what happens is we get a mixture of these products when we carry out the halogenation. Now this reaction I started with the halogen. What the topic that we are talking about is we are starting with this. The end result or the products are still the same. We are going to get a mixture of the products which are not easy to separate under common laboratory conditions. Next we've got is the Friedel-Crafts alkylation. What is Friedel-Crafts alkylation? You've got an alkyl halide, you react it with benzene. Of course, there are variations, there are other conditions, there are other compounds also which undergo this reaction. I am explaining the basic one, then when we shall cover it in greater detail in aromatic chemistry. So, we've got anhydrous AlCl3 as one of the catalyst, and the hydrogen of the benzene ring gets replaced by an alkyl group, giving us what we call as alkyl benzene. So, okay, what if this alkyl group is CH3? What will be your product? Very good. In the product also you replace the R by CH3, and this gives us what we call as either methyl benzene or more commonly known as toluene. See how aliphatic and aromatic compounds are connected to each other? Let's go on to the last reaction in our table, and that is the rearrangement or the isomerization reaction. Again, we have talked about isomerization in alkanes also. Iso is same, mer is molecule. That means when they get converted into the same molecular formula, but the structure may be different. So, for example, if I have Cl, of course the others are hydrogen, CH3, CH2, CH2Cl. On isomerization in the presence of anhydrous AlCl3 at a temperature of around 573 Kelvin, what will happen? It will get converted into a 2-chloro derivative. The number of hydrogen, carbon and chlorine atoms still remains the same. How? Let's check. 1 carbon, 2 carbon, 3 carbon, 1 carbon, 2 carbon, 3 carbon. Check hydrogen, 1, 2, 3, 4, 5, 6, 7. 3 plus 3, 6 and 1, 7. 1 chlorine, 1 chlorine. So, if you notice over here, the formula has remained the same, but the structure has changed, and that is why they are called isomers, compounds having the same molecular formula but differing in the arrangement of their atoms. So, hope that this flowchart was useful for you and you would have noted it down and would take maximum benefit out of it. You can add or eliminate reactions from these according to your course curriculum or according to your requirements. So, in case it is not prescribed by your curriculum or syllabus, but still you want to learn something new, please feel free to use the flow chart to enhance your learning. These flow charts are very useful to have a bird's eye view of any organic compound and to make your learning more interesting. Please stay connected because the series of videos continues. Stay happy and smiling always. And if you feel connected to the learning, please share this joy with your friends. Teach them. Direct them to the channel if you are unable to. You can always lend a helping hand to your peer group. Happy learning to all of you.